good morning everyone. Today we're going to continue with word problems. Let's take a look at question number 1. Question number 1, it says that there are 700 people in line for a popular amusement park ride. When the ride began operation in the morning, in the beginning there are 700 people waiting already. Once it begins operation, the ride accepts passenger until the park closes 8 hours later. So it tells us the time interval is 0 to 8. While there is a line, people move on to the ride at a rate of 800 people per hour. The graph above, the bit right here, shows the rate RT at which the people arrive at the ride throughout the day. So you put this together, it basically means 800 people are leaving the line, per hour. So the people leaving the line are 800 people per hour. And the people are entering the ride at the rate of RT. So here, they give us the rate out and the rate in. So even though the question changed into people in the amusement park, so the concept is the same. So at t equal to 0, there are 700 people waiting already. That's an initial amount. So people, leaving the line is 100 people per hour. And people entering the line is RT. That's also measure people per hour. So we got the rate in and the rate out also, if you call it this way. So basically this is the whole idea about just like the water problem. So if you let P or P of T or P of X equal to the number of people in line, then we got P of X equal to integral 0 to X, the people entering rate, dt minus 0 to X, the rate people leaving, n plus 700. So we got P of X equal to 0 to X. So entering is RT and leaving is 800. So this is the whole idea about this whole problem. So it's very similar to the water problem. Now let's take a look at part A. So how many people arrive at the ride? So that means it has something to do with the R of t between t equals 0 and t equals 3. Show the computation. So we have to find number of people arrive. So it will be the 0 to 3 rate in dt. And find the number of people arrived. That will be equal to integral 0 to 3 rate in dt. So now we're going to be 0 to 3. The rate in is r of t. So we're going to find the integral 0 to 3 rt dt. And rt is the graph. So we're going to use the area under the curve. So we're going to use what we learned before to find the area under the curve. So everything's above the x-axis, so therefore everything will be positive when we find the integral. 1, 2, 3. 3 is right here. So we're going to find the area if you look at this shape, it's irregular, so we have to cut them into some shade that we know, so we know some shade that we are familiar with. So I'm going to cut it into two trapezoid. You have a big one and a small one. So over here we got 0 to 1,000, so we got 1,000, 0 to 1,200, so this is 2 gamma 1,200, so that was 1,200, and here is 3 comma 800, so we got this is 800. So now we are going to calculate the area. So we have base 1, base 2, and the height equal 2. So we go back over here, we get 1/2, 1,000 plus 1,200 times 2. And this one, the height equal 1. So we got 1,200 as the base 1 and 800 as the base 2. Now we're going to calculate. 2,200, and then we had to add this, you got 2,000, and then we're going to get 2,200 plus 1,000, so we got 3,200 people. So 3,200 people enter the park, right, from 0 to 3. In other words, 3,200 people arrive. Let's take a look at part B. Is the number of people waiting in line. The number of people waiting in line is basically P of T or P of X. To get on the right, increasing or decreasing between the time t equal 2 to t equal 3, just to find your answer. So if you translate it, basically the answer is P of X or P of T increasing or decreasing on the interval 2 to 3. It never say inclusive, so therefore there's no equal sign. So we say that we're going to use P prime, that one-on-one number over here. So we continue. We say that if you have, okay, the P of X equal to 0 to X, so we got RT dt minus 0 to X, this is 800 dt plus 700. So P prime is going to be the rate in minus the rate out, which is RT minus 800. So now we're going to check, see P prime is positive or negative. So check P prime is positive or negative on the interval 2 to 3. So because RT is a graph, we definitely cannot type it in a calculator, so we have to look at the graph. So let's take a look at the graph over here. 2 to 3 is this part. At 3, we get 800. At 2, we get 1,200. So this will be like 801, 802, 803. Okay. So in other words, over here, RT definitely is going to be bigger than 800 on the interval 2 to 3. RT is bigger than 800. At 3 is 800. Definitely everything else is bigger than 800. So if we have a number that's bigger than 800, for example 801, subtract 800, then RT is positive. So we can say RT minus 800 equal to positive. Then P prime is positive on the interval 2 to 3. Then we can say the number of people in line is increasing. So we finished question 1b. Let's take a look at 1c. At what time t is the line for the ride the longest? The line the longest. So that means p of x is the absolute max. So we're still going to find the absolute max like the other problems. So part C, to find p of x as absolute max. So we're going to use p prime equal to 0, just like what we did before. So from part B, we know that p prime equal to RT minus 800. So we're going to make RT minus 800 equal to 0. And we cannot substitute this into a calculator or type in a calculator because RT is a graph given over here. So let's take a look at, okay, what would happen, okay? So because RT is a graph, so I'm going to plus 800 both sides first. So RT equal 800 at when? So find when RT equal to 800. So 800 is over here, and we got the point 3 comma 800. So that means t equal 3. At t equal to 3, RT equal to 800. At t equal 3, p prime equals 0. So we found the critical value. Now we're going to do a little bit of side chart. So we got 0, and then we got 3, and then we got 8. So let's take a look at the p prime, which is RT minus 800. So you can do the regular way over here. So pick a number between 0 and 3, let's say 2. So at 2, you get 1,200 and subtract 800, so it's positive. Let's pick a number after 3, let's say 4. You got 400. 400 minus 800 is negative. So now we're going to get P0, P3, P8. So we got the P3 is a relative max, and it's the only relative max, so therefore it's absolute max. So P3 is the only relative max. So it is the absolute max. So the line is the longest at t equal 3. And they also ask about how many people. So we have to find P3. So we just do 0 to 3. RT dt minus 0 to 3, 800 dt, and plus 700. So from the previous part, we found out that integral from 0 to 3 RT dt is 3,200. So we just had to calculate this part over here. So we subtract 2,400 minus 0. And then we're going to calculate over here. So to subtract this will give you 800, and then plus 700. And then we get 1,500 people. So at t equal 3, there are 1,500 people. So we finished part C. Now let's take a look at part D. Write but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line. So that means 0. There's no more line. So that means the number that goes in minus the number of people goes out, and plus 700, you get 0. And we have to use the time t. So 0 to t and r. So since I already used t over here, so I had to use other letter. So let's use x. So integral 0 to t, 800. We have to just change into x, and plus 700 equal to 0. So that means the number of people going in subtract the number of people going out, and plus 700, you get 0. That is when no longer a line for the right. So we finish part D.